Welcome to Scale Up University. Welcome to the course on Power Plant Engineering. So, this is the lecture 2 of Module 1, Overview of Power Generation Systems. So, in the previous lecture, we saw the importance of electricity, like why electricity is central to modern society. That is what we discussed in the previous lecture. Now, this lecture, the focus will be how electricity is produced, organized, and delivered at a national scale. So we will get an overview. Like in this lecture, it is not like we will go very deep. Rather, we'll get an overview of power generation systems, as in how electricity is produced, organized, and delivered at a national scale. So in this lecture, we will be answering questions like what a power plant is, how energy conversion occurs, how power plants are classified, and how electricity flows, like from generators to consumers, because electricity is produced via generators, and then how it gets to the end user, the consumers. So how electricity flows. So we'll get a very good understanding, like an overview. So we will be able to answer all these questions by the end of this lecture. And this lecture is a very important foundation. It's an essential foundation. So before diving deep into individual technologies, it's very important for us to get an overview of power generation systems, and that is what this lecture is about. So if we look at the topics we will be covering in this lecture, so we'll talk about introduction to power plant, basic concept of energy conversion in power plants, classification of power plants, centralized versus decentralized power generation, grid connected power generation, integrated view of power generation systems. So all this we will cover in this lecture, all these topics one by one. So this is the module 1, economics of power generation, lecture 2, overview of power generation systems. And we are starting with the first topic of this lecture, that is introduction to power plant. So what is a power plant? So power plant basically an industrial facility where primary energy is converted into electrical energy in a controlled, continuous, and economical manner. So power plant is basically an industrial facility where the primary energy it is converted into electrical energy. Now, what are the primary energy sources? So these are like some primary energy sources, like we have coal, gas, nuclear, hydro, solar, wind. So these are like primary energy sources. So an industrial facility where primary energy is converted into electrical energy. So in a power plant, these energy sources like coal, hydro, solar, wind, gas, nuclear, these are converted into electrical energy in a controlled, continuous, and economical manner. This is very important. So it's a controlled environment wherein we can control the conversion of primary energy into electrical energy. This conversion is continuous in nature. Like we will keep on producing electrical energy, and economics play a very important role. So we produce power in an economical manner. So as we can see here, so the fuel or the natural energy source, that's a primary energy source, we convert it into first mechanical energy, either by heating gases or burning coal, because when we burn the coal, heat will generate it, and that heat, when passed through water, steam will be generated, and that steam we will use to rotate the turbines. And that is the mechanical energy. So we converted it into mechanical energy. And rotating turbines, we know the concept of electromagnetic induction. So magnets are there. So when the magnets rotate, so there is a change in magnetic field. It will induce an potential difference, like a electric field, and hence electrical energy will get created. And this electrical energy, it powers grid, cities, and industries. So now we got a very good understanding of power plant, like what is a power plant. Now, if we talk about key functions of a power plant, what are the key functions of a power plant? So power plants are responsible for generating electricity reliably. Like, and what is the meaning of reliable here? Stable supply. So power plant, they ensure stable supply of electricity. And hence we see that if you look around you will see the supply of electricity is relatively stable. And because of power plants, they ensure reliable electricity generation, meet variable load demand. So power plants, they work to meet variable load demand. Like there may be daily peak and off peak scenarios. So power plants can handle that. Operate economically. This is very important. Electricity generation should be economical, and that's the key function of a power plant, so that electricity is like cost effective. So cost efficiency is very important. So power plants, they operate economically and also maintain safety and environmental standards. So power plant should not turn into a environmental hazard. So power plants, they maintain safety and emission control. So if I talk about key functions of a power plant, it is to generate electricity reliably, meet variable load demand, operate economically, maintain safety and environmental standards. So we can say that power plant is not just a machine, or it's not just like a machinery, rather it's a complex engineering system. It's a complex engineering system. Basic concept of energy conversion in power plants. So if we talk about energy conversion, like the energy conversion chain, so every power plant, it follows a energy conversion chain. So what happens is we start with a primary energy source. Now this primary energy source, it can be coal, oil, gas, nuclear, water, wind, or solar. So this primary energy source, we convert it into thermal or kinetic energy. So we start with a primary energy source and we convert it into thermal or kinetic energy, like the steam, hot gases, flowing water, moving air. Like if we generate the heat, then from the heat we can get steam, hot gases, flowing water, moving air. So this is like the thermal or kinetic energy we got, and then we convert the thermal or kinetic energy into mechanical energy, wherein we use that thermal energy or the kinetic energy generated in rotating turbines, turbine rotation. And when the turbine will rotate, magnets will be there, magnet will rotate, some mechanism will be there. So change in magnetic field, it will produce electric field. So electrical energy will produce, and that is the generator output we get. So this is the energy conversion chain, which is basically uh, followed in power plants. Now here one very important observation, like whenever conversion is happening, there is some loss is happening. Like when primary energy is getting converted into thermal or kinetic energy, losses will be there in the form of heat, friction. When thermal or kinetic energy is converted into mechanical energy, there will be efficiency limitations, because we have already studied in thermodynamics that like Carnot cycle, it is not 100% ideal. Like it's not ideal. Efficiency is not 100%. So efficiency limitations is always there in the real systems we work with. So when thermal or kinetic energy is converted into mechanical energy, efficiency limitations will be there. And when mechanical energy will be converted into electrical energy, cost implications will be there, like fuel, maintenance cost, capital. So every conversion has some challenges associated with it, wherein primary energy conversion to thermal or kinetic energy losses will be a challenge. Thermal energy conversion into mechanical energy, efficiency limitations will be a challenge, and mechanical energy conversion into electrical energy, cost implications will be a challenge. So the idea is each conversion stage introduces losses and costs. If we look at a real example of it, like if we consider a thermal power plant, so as the name suggests, thermal power plant, so the heat plays a very important role in thermal power plant. So it is coal fired. So how it works is very important discussion we are making. So in a thermal power plant, we start with coal, we burn the coal. So when we burn the coal, heat energy will get created, and this heat will be used to boil water, and hence steam will be generated, and then that steam, because we know na steam will carry like gas particles with very high kinetic energy, and they are strong enough to rotate this turbine. So because of that steam, the turbine will get rotated, and the rotating turbine will generate the electricity. So this is how electricity is generated in the thermal power plant. So this multi-stage conversion is why efficiency and economics are deeply linked. Now, here there is a scope of optimization, because we know that in each conversion stage introduces losses and costs. So we can optimize the cost and also the loss, like we can minimize the loss, minimize the cost. So because of this multi-stage conversion, efficiency and economics are deeply linked in power plants. Now there is a question for you. You can comment your answers. So according to you, where are the biggest losses? Like in generating electricity, where are the biggest losses? Classification of power plants. So now we will be classifying power plants from an engineering perspective. So we can classify power plants based on energy sources. So based on energy source, we can have conventional energy based power plants. So conventional energy means non-renewable. Like these energies are, we cannot renew it. So we have conventional energy based power plants like thermal power plants. So in thermal power plants, we make use of coal, oil, or gas to generate electric power. We have hydroelectric plant and nuclear plants. So thermal power plants, hydroelectric power plants, and nuclear power plants, they are conventional energy based power plants. Now, conventional energy based power plants, they follow certain properties, like they have very large installed capacity, means they can generate huge power. They have centralized operation, and they are grid dependent on grid. So the idea is that conventional energy based power plants, they are centralized and they're grid based. So we have to distribute over long distances. They are huge, they are centralized, and they're grid dependent. On the other hand, if we talk about non-conventional or renewable power plants, so here we have solar power plants where sun is the primary source of energy to generate electricity. Then we have wind power plants where wind is the primary source of energy. We have biomass plants, and we have tidal and geothermal power plants. Now, in this renewable or non-conventional power plants, if we look at the features, it is environmental friendly. It is environment friendly. It is location dependent. So this is very important, because if you are planning to set up a solar power plant, and if you are like planning for a location where the sun rays are very rare, then it will not work. So you have to find a place where you get a very high intense sun rays. There that power plant will work. So non-conventional power plants, they are location dependent, wherein if wind power plants we have to set up in those regions where we see lots of wind. They are often intermittent, means we cannot expect them to work continuously, because if I talk about solar power plants, in the night they will not at all work, because in the night there will be no solar. Wind power plants, they will not work uh, when there is no wind. So they can have a they can pause in between, like it's not like they will operate continuously. So that's why the install capacity is limited, and they are like decentralized in nature. Decentralized in that sense that wherever the energy source is there, we set up the power plants over there, and from there we distribute it. We generate the power and we distribute the power. So this was the classification of power plants based on energy source. Now we'll talk about the classification based on technology. Classification of power plants based on technology. So based on thermal technology, thermal is the heat. We have steam power plants, we have gas turbine power plants, we have diesel engine power plants, and we have combined cycle power plants. So based on the thermal technology, we have steam power plants, gas turbine power plants. So steam power plants, we can very easily get an idea that first we heat or we burn the primary energy source, or using the primary energy source, first we will create the steam, and that steam will rotate the turbines, and hence we will generate the power. Gas turbine, hot air or hot gases, they will rotate the turbine. In the diesel engine power plants, we will make use of the diesel as the fuel. So burning of diesel will generate heat, and that heat will like rotate the turbines. And we have combined cycle. Now the next technology is the nuclear technology. So in the nuclear technology, we have fission based reactors, which acts like the power plant. So nuclear fission, you know the reaction. So fission means breaking of atom. So when the atom you break it, either colliding two atoms, when the atoms will break, huge energy will get emitted, and that energy is used to rotate the turbine and hence generate electricity. So we have power plants based on nuclear technology, like fission based reactors. And so here what is happening is, as I said already, heat is generated via nuclear reactions in nuclear technology. Then we have hydraulic technology. So hydraulic technology, you might have heard about hydroelectric power plants. So energy from stored or flowing water, we make use of it to rotate hydraulic turbines. So hydraulic turbines, they get rotated from the like via the energy from stored or flowing water, and with that electricity will be generated. And there are like many emerging technologies also which are powering the power plants. So we have solar photovoltaic power plants based on the solar photovoltaic technology, solar thermal fuel cells. So these are the future trends. Now we have power plants which are powered by fuel cells. So these are the classification of power plants based on the technology. Now we can also classify power plants based on operating characteristics. And this is very important discussion, especially from the context of economics and planning. So we have base load power plants. So base load power plant, what's their objective? Their objective is to operate continuously. Their goal is to supply power continuously 24 cross 7, supply minimum constant demand. Now they have very large capacity, so high capital cost. So base load power plants, they have a large installed capacity, so high capital cost and low operating cost. Examples of base load power plants are thermal and nuclear. These are like base load power plants. Then we have peak load power plants. So they are used to serve or to generate power only during the peak demand. They will not generate power continuously. They operate during high demand. They have quick start and stop functionality. They have lower capital cost, higher operating cost. Examples are gas turbine power plants, diesel power plants, and pumped storage power plants. Then we also have intermediate load plants. So these power plants, they operate between base and peak and they balance system economics. So this was the power plant classifications from engineering perspective. Centralized versus decentralized power generation. So if we talk about the concept of centralized generation, so here what happens is in centralized generation, we have large power plants situated near fuel or water sources, which are the primary energy sources, and they generate electricity and they are grid dependent. So electricity is transmitted over long distances. So that is the main concept of centralized generation, centralized power generation. So if we talk about the advantages, so since they are large power plants, so economies of scale we achieve because large power plants, if we scale also, we will achieve economies of scale. High efficiency we achieve, better control and monitoring we achieve. So centralized power generation, better control and monitoring, high efficiency, economies of scale. If we talk about limitations, now since it is grid dependent, electricity transmitted over long distances is involved. So definitely high transmission losses will be there. High transmission losses will be there. Large capital investment will be there because like their large high capital is needed. They are dependent on grid dependency, and they are vulnerable to failure, vulnerability to failures. So these are like limitations of centralized power generation. Now, if we talk about concept of decentralized power generation, so we have something like rooftop solar. So here, a single house is able to generate electric power, or a micro hydel plant nearby a very small water source. It can generate a electricity. It can generate electricity. Now, decentralized generation, the main feature of it is located near load centers. If we look at some more examples, biomass based local plants, like from the biomass we can generate electricity. So small to medium plants, often renewable based. So these decentralized power generation, it mainly makes use of renewable source of energy. uh, the power plants are small to medium sized and they are located near the load center itself. So these are like the features of centralized decentralized generation. If I talk about the advantages of decentralized power generation, we have reduced transmission losses because now since it is located near the load centers, no need for electricity transmission over long distances. So by default, there will be reduced transmission losses, faster deployment, suitable for remote areas, improved energy access. If I talk about challenges, so these decentralized power generation, it is not continuous. Intermittency is there. Like because renewable energy in the night, if we are talking about rooftop solar, in the night it cannot generate electricity. Now here grid integration issues are there because here we have to set up new grid, different type of a grid, or to integrate these power plants, decentralized power plants to the main grid, it is an issue. And also there is a challenge of high per unit cost in some cases. In some cases, electricity generation will be very expensive, so high per unit cost will be there. So this was the difference we saw between the centralized power generation versus the decentralized power generation. So if we look into this table, so we will be looking at aspect for centralized and decentralized. So for the aspect of plant size, okay, so centralized power plants, they are very large in size, the plant size, and decentralized are small to medium size. If I talk about location, so centralized power plants or the centralized power generation, they are located near fuel sources, and decentralized power plants, they are located near load. If I talk about transmission, so for centralized power plants, it involves long distance power transmission, and for decentralized power plants, the transmission is minimal. If I talk about reliability, so centralized power plants, they're dependent on grid dependent, and decentralized are local reliability. And if I talk about capital cost, for centralized it is very high, and for decentralized it is low. Grid connected power generation. So first let us understand what is an electric grid. What do we mean by an electric grid? So basically, electric grid is a network of power generating stations, transmission lines, substations, and distribution networks. So if we try to visualize the grid, so here we have a grid. So grid is basically a network, electric grid. Electric grid is basically a network of power generating stations where electric power is generated, the power plants. It is a network of transmission lines. So then we have substations in the picture in the electric grid, and then the distribution networks. So electric grid is a network consisting of power generating stations, transmission lines, substations, and distribution networks. And if we talk about role of grid in power generation, it balances supply and demand. This grid, the very important role is to balance supply and demand. It enables load sharing between plants, because all the power plants are the part of the grid. So load sharing between power plants are possible because of the electric grid. Electric grid, it improves system reliability, and it allows optimal plant dispatch. So electric grid plays a very important role in power generation, wherein it balances supply and demand. Electric grid enables load sharing between plants. Electric grid improves system reliability, and electric grid, it allows optimal plant dispatch. And if I talk about importance of grid connectivity, so see, power plants, they rarely operate in isolation. Now electric grid operation, it ensures frequency control, voltage regulation, and system stability. So the electric grid, it and this electric grid connectivity, it's very important because it ensures frequency control, voltage regulation, and system stability. So this was the grid connected power generation. Integrated view of power generation systems. Now, if we talk about a modern power system, or the modern power system, it's a mix of different power plants. We discussed so many different types of power plants, like thermal power plants, hydroelectric power plants, nuclear power plants, wind energy based power plants, solar power plants, and so on. So modern power system is a mix of different power plants. Modern power system, it is operating at different load levels. So we have dedicated power plants for base load, peak load, and intermediate load. Modern power system, it is coordinated through a electric grid, and it is optimized for minimum cost and maximum reliability. So the integrated view, so this integrated view, which we saw, it sets the foundation for load curve analysis because of the electric grid, because the power plants, they are interconnected through the electric grid. We can balance the demand and supply. We can also perform load curve analysis. We can deal with plant economics, and we can also do the capacity planning. So this electric grid, or the integrated aspect of power generation systems, it enables us to do capacity planning, plant economics. It sets the foundation for load curve analysis. So finally, we completed this lecture. So in this lecture, we looked at what a power plant is, how energy conversion takes place in a power plant, classification of power plants, differences between centralized and decentralized power generation, and the role of grid connected operations. I hope you got a very good understanding of the concepts which we discussed in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.